Okay, the topic for today's lecture is thermodynamics. So first we'll try to understand what is meant by thermodynamics and what are its uses and what are the different types of thermodynamic systems and different concepts regarding the thermodynamics. So let us now try to see firstly what is meant by thermodynamics. The definition of thermodynamics, it goes out like this, where this thermodynamics is mainly regarding the exchanging of the heat. It is mainly regarding the exchanging of the heat between the two different bodies or else between a body and its surrounding area. So now the exchanging, whenever the exchanging of heat takes place between two different bodies and the surrounding area, we call this particular concept as an thermodynamical concept. So now in the thermodynamics, it is defined as the branch of science of the physical science or the science which mainly deals with exchange of heat energy. It means that here the exchanging of heat energy takes place. So where does this exchange of heat energy takes place? The exchanging of the heat energy will be happening between two bodies, between bodies, or between body and surrounding area. So now let me explain you to make you understand that what is exchanging of heat between body and surrounding area. So I'll take an example which is very simple and easy to understand, in a which you can call it as a real-time example. So let me take an example of cup of milk. If I take a cup of milk in a glass, definitely what happens? The heat from the milk will be exchanged to the vessel or to the glass. So that is called as an exchange of heat energy between two different bodies. That is called as an exchange of heat energy between two different bodies. So now, if I try to consider the particular heat energy between hot water in a bucket and the surrounding area, definitely what happens? In the winter season, the heat energy from the hot water will get transferred from a bucket full of water to the surrounding area. It means that the transferring of heat takes place here until the temperature in the hot water and the surrounding area will become the same. It means that the transferring takes place until both these two different environments will have the same temperature, and this concept we know that we call it as an thermal equilibrium. So once the thermal equilibrium has been obtained or attained, we can say that the transfer of heat energy will be stopped. So that is called as an exchanging of heat energy between a body and the surrounding area. So now, what is thermodynamics? It is a branch of physical science which mainly deals with the exchange of heat energy between the bodies, between the two different bodies, and between body and a surrounding area. So how to consider the exchange of energy between two different bodies? So let me give another example. If I am having one hot body, let me take one vessel which is hot, and if I try to put another container or a lid of that vessel upon the hot vessel, what happens? Within no time, even the lid of that particular vessel will become hot. So here the exchanging of heat energy is taking place from the vessel to the lid. So that is called as an exchange of heat energy between the two different bodies. And this is a definition of thermodynamics. And apart from this, in the thermodynamics, the conversions of the energies takes place. It means that conversion of heat energy will take place into different forms of energy. And also the conversions, it is about the study of conversion of heat energy into different forms of energy, So what is this different forms of energy? The conversion of heat energy, or it can be even the vice versa. It can be even the vice versa, from different forms of energy to the heat energy. So now let us understand what is this conversion of heat energy into different forms of energy. So it is, thermodynamics is also about the conversion of heat energy into different forms of energy. It means that here the heat energy can be converted into electrical energy, it can be converted into electrical energy, or else it can be converted into mechanical energy, it can be converted into the chemical energy. Is it okay? So now these are called as a conversions of heat energy into different forms of energy, and also it can be even the reverse operation, that is nothing else from the electrical energy to the heat energy, or else chemical energy to the heat energy, or mechanical energy to the heat energy. So see, let us take an example, like if I rub my both the hands, I am doing some mechanical process here. The rubbing of the hands is nothing else but it is a mechanical process is happening. So now that mechanical process will yield me heat energy in my hands. So that is called as a mechanical energy, or your muscular energy. The energy from the muscles is being converted into heat energy. So this is called as conversion of heat energy into another form, or else from another form of energy to the heat energy. So this is regarding what is meant by thermodynamics. You can copy it down. Next, what is meant by thermodynamic system? What is meant by thermodynamic system? Thermodynamic system means it is some part of the universe. If you are having any, if you take universe into consideration, thermodynamic system is a part of the universe where the thermodynamic concepts are studied with direct observations. With direct observation means you will be studying the thermodynamic concepts with respect to some keen observations, that is called as a thermodynamic system. Let me put it one example here. Let me consider here the room in which right now you are sitting and listening this lecture. Let this be the room in which you are right now sitting and listening this particular lecture, and let me assume that your room is having one window, and the window is open now. Window is open. Once the window is open, what happens here? Once the window is open, we know that the air will be flowing in and flowing out of your particular room. The air from the outside will flows into the room, and also the air from the room will be flowing out of the room. So now what is actually happening? There is some kind of exchanging of your matter is taking place. We know that gas, air is nothing else but air is a form of gas. So now here, once the air is entering into the room and from the room it is going out of the room, we say that exchanging of matter is taking place. So now this exchanging of matter is nothing else but we have studied, it is called as in thermodynamics. So now once if I consider this room, if the exchanging of matter is taking place, we call some thermodynamic concepts are happening here, some thermodynamic applications are happening here. So that kind of smallest area in a universe where the thermodynamic concepts are being studied with keen observation into that particular small area, that is called as a system. So now this is a system, this part is a system. The system will be always having a boundary. The system will be, thermodynamic system will be always having a boundary. So this part we call as a boundary, and then the area surrounding this one, which I can denote it as with this different color. So this one I can call it as an surroundings. This is called as a surrounding, this is called as surrounding, and this is called as a boundary of the system, and this one is called as a thermodynamic system. So thermodynamic system is what Thermodynamic system is a part of the universe where the thermodynamic applications are studied directly with keen observations. So this particular region we call it as a thermodynamic system. So now, what does the thermodynamic system has? The thermodynamic system will be having, I have given an example that air is flowing into your room. If air is flowing into a room, what does it mean? The air is nothing else but it's a gaseous state of matter. So now a large number of molecules and large number of atoms are present in your thermodynamic system. There will be a large number of atoms and large number of molecules in your thermodynamic system. So now this first one, in the thermodynamic system, there will be extremely large number of atoms and molecules. It will be having extremely large number of atoms and molecules. Then second one, this particular thermodynamic system is a boundarified area. It is confined to one particular area. This system is a confined area. Confined area means what? This thermodynamic system will be having some particular boundary. It will be having some particular boundary. Then third one, your thermodynamic system, the region around this one, the region around the thermodynamic system, we call it as a surrounding. If there is a surrounding at a thermodynamic system, then definitely what happens? Then definitely there will be an exchange of matter takes place. Exchange of matter takes place and also exchange of heat energy, that is nothing else but energy takes place. So now see, let me consider in the summer days what happens. We know that as the air blows into our room, it is not only the air which is blowing into the room, but at the same time, along with the air, the hotness of that particular air is blowing. It means that there is some kind of radiation exchange. Once the hot air blows into the room, the cool air will be going out. It means that there is an exchange of energy. The hotness is entering and the cool temperature is going out. So it's an exchange of energy. And at the same time, the air which is going into the room and also at the same time it will be coming out of the room. So at the same time, simultaneously, both the things are happening. Exchange of matter is taking place and also exchanging of energy is taking place. So this is the major property of thermodynamic system. A thermodynamic system, first it will be having a large number of molecules and also large number of atoms. Then secondly, it will be a confined area. It will be having some boundary, and this is called as a boundary. And then there will be some surrounding area. The area around this one, the area outside this system is called as an surrounding area. So now this is the main parameters of what is meant by thermodynamic system. I hope you understood what is meant by thermodynamic system. Okay, the next concept is types of thermodynamic systems. So let us now try to understand what is meant by types of thermodynamic system. So see now, in general there are three different types of thermodynamic systems. First one is called as an open system, then second one is called as an closed system, then third one is called as an isolated system. So now here, first one is called as an open system, second one is called as an closed system, third one is called as an isolated system. So now let us understand in detail about what is meant by open system, what is meant by isolated system, and what is meant by closed system. So see now, if it is an open system, in the open system, the exchange of matter and also exchange of energy will be taking place. In the open system, exchange of matter. Matter means what? It can be exchanging of solid state matter, it can be exchanging of liquid state matter, or else it can be exchanging of gaseous state matter. So now here we are talking about any state of matter. It can be exchanging of solid state matter or liquid state matter, or else gaseous state matter. So now in the open system there will be exchange of matter and energy. Both the energy and matter will be exchanged. Both the energy and matter will be exchanged. Now coming to the closed system. In the closed system, exchange of energy takes place. Energy takes place, but not matter. So matter exchange will not happen here. Only it will be an exchange of energy. So exchange of energy takes place here in case of closed system. Now coming to the isolated system, neither matter nor energy is exchanged. So listen here, ma'am. So now let us understand in detail with an example what is meant by open system, what is meant by closed system, and what is meant by isolated system. Up to now I have told that in an open system it will be an exchange of matter and also exchange of energy. In closed system it will be exchange of energy, but not the exchange of matter will takes place. But when it comes to the isolated system, neither matter nor the energy will be exchanged. So let me give you one example how to understand these concepts of open system, isolated system, and also the closed system. I hope you all are aware about pressure cookers. Always I like to explain with the real-time example so that the physics can become more easy for you to understand. So see now, I hope that you all are aware about pressure cookers. Now let me assume that the whistle of the pressure cooker is closed. It means that it is not blown up. Whenever the whistle is not blown up, if we have started the pressure cooker to work under the burner, so what happens? If once the burner is on, the temperature from the burner will be caught by the pressure cooker, and the temperature of the pressure cooker will be increased. Once the temperature of the pressure cooker is increased, what happens? We can sense that heat energy of that particular pressure cooker. If the heat energy of the pressure cooker is increased, means if you touch the pressure cooker, you can understand that the pressure cooker is turned on. If the pressure cooker has the temperature in the pressure cooker is increased. That thing we call it as an what has happened here. The whistle has not blown, but the heat energy is exchanging. There is an exchange of heat energy. So we can say that it's only the exchanging part of heat energy. It's only an exchanging part of heat energy, but not the exchanging of matter. Exchanging of matter is not taking place. So for that one, I can call the state of the pressure cooker when the whistle is not blown, I can call it as an closed system. Only the heat energy is exchanging. Only the heat energy is exchanging, but not the matter is exchanged. That is a closed system. So what is the definition of closed system? The exchange of energy takes place. That's a heat energy. Here in my case, it's a heat energy, but not the matter. Matter exchange is not happening here. Now let me come to the case that once the whistle of the pressure cooker is blown, if the whistle of the pressure cooker is blown, what happens? The exchange of matter also takes place. The air which is present in the pressure cooker comes out of that particular pressure cooker through the whistle. So now ultimately, in this particular phase of the pressure cooker, the heat energy can also be released into the environment or into the surrounding area, and at the same time, once the whistle is blown up, the energy, that's the air from the pressure cooker, will be coming out of the whistle. So now here both the exchanging of energy and also exchanging of matter is taking place. So here matter means what? The gas which is released through the whistle of the pressure cooker. So that's why I can call this phase of the pressure cooker as an open system. It's an open thermodynamic system. So this is regarding what is meant by open thermodynamic system and what is meant by closed thermodynamic system. Now let me come to the isolated system. In the isolated system, there will be neither exchanging of matter nor the exchanging of energy will be taking place. it means that your thermodynamic system is a rigid and it is a completely isolated one. Isolated one means I can call it as an what to say here, it acts as an barrier to the exchanging of this matter and also the energy. The best example for this one I can give as a thermo flask. If you take a thermal flask, what happens when you pour the hot water or hot coffee or hot anything, hot liquid into a thermal flask? We know that the inductive part that which acts as an insulator, the insulator will protect the particular liquid, the temperature of particular liquid to be exchanged into the surrounding area. It means that the heat energy from the liquid which is hot right now in the particular flask will not be coming out of that particular thermal flask. So there is no exchanging of heat energy taking place, and also the matter is not exchanged until and unless you try to use a thermal flask for pouring out of a coffee into a cup or else hot water into any glass. The matter will not be exchanged. So now the example of a isolated thermodynamic system will be thermal flask, and the example of open system and the closed system will be two different phases of how a particular pressure cooker will be working. So this is about what is meant by different types of thermodynamic system. There are three different types of thermodynamic system. First one is called as an open system, second one is called as an closed system, and the third one is called as an isolated system. Next topic is thermodynamics variables and equation of state. Thermodynamics variables and equation of state. So let us understand now the concept of thermodynamics variable. See, any thermodynamic system will be described or defined or specified by using some parameters. There are some macroscopic and microscopic parameters which will define what kind of that particular system is, what kind of particular system is. See, while studying about some gas laws, we have come across a concept called isochoric process, isobaric process, and isothermal process. So all this process are nothing else but these are some types of process which are related to the thermodynamics system. So now thermodynamic system is nothing else but what is meant by thermodynamic system? The thermodynamic system is a system which is confined to some area in the entire universe. So now that particular thermodynamic system can be specified or can be described or can be defined with respect to some parameters, some microscopic or macroscopic parameters such as pressure, volume, temperature, internal energy, number of moles. All these are the different kinds of parameters. If you can define any kind of thermodynamic system with respect to these parameters, we call these parameters as in thermodynamics variables. The parameters which define or which specify or which describe a particular thermodynamic system is called as in thermodynamics variables. So thermodynamic variables are what? The parameters which define or describe the thermodynamic system is called thermodynamic variables. Thermodynamic variables. So what are these thermodynamic variables here? The variables are like pressure, volume, temperature, number of moles, and internal energy. So now the thermodynamic variables are nothing else but these are the parameters which will be defining what kind of system is that particular thermodynamic system. So whenever a thermodynamic parameter or a variable which defines the thermodynamic system, we call those kind of parameters as in thermodynamic variables. So now let us see the relationship between these thermodynamic variables. the relationship between thermodynamic variables is PV equal to nRT. PV equal to nRT. We have studied this particular concept of PV equal to nRT while studying the concept of what is meant by ideal gas equation. What is meant by ideal gas equation? During that particular time we have studied PV equal to nRT. What is P here? P is the pressure, V is the volume, N is the number of moles, R is what? R is the universal gas constant, and T is the temperature. Can anyone tell me what is the value of R? R is a universal gas constant. What is the value of R? 8.31? 8.31, right? So now, okay, so that is a universal gas constant. If you can make a relationship between thermodynamic variables, we call that related part as an equation of state. So now this one, this is called as this equation is called as an equation of states. Equation of states. If my number of moles equal to 1, my equation of state becomes PV equal to RT. PV equal to RT. So this is regarding what is meant by thermodynamic variables and what is meant by equation of state. I hope you might have understood regarding this equation of state. When you can make a relationship between the thermodynamic variables, we call it as an equation of state. If number of moles is equal to 1, then the equation of state becomes PV equal to RT. Now let us see some different types of thermodynamical process. We have seen now up to now what is meant by thermodynamic process. Now let us try to understand and try to know some few different types of thermodynamic process. So now different types of thermodynamic process. Different thermodynamic process. First one, isothermal process. Second one, isobaric process. Third one, isochoric process. Then fourth one, adiabatic process. Adiabatic process. Then fifth one, cyclic and non-cyclic process. Then sixth one, reversible and irreversible process. So now these are the different types of thermodynamic processes. The first one we call which is a isothermal process. Second one is a isobaric process. Third one is an isochoric process. Fourth one is an adiabatic process. Fifth one is a cyclic and non-cyclic process. Sixth one is an reversible and irreversible process. So now let us understand in brief what is meant by all different types of process. If it is an isothermal process, in the isothermal process, the temperature is constant. Temperature is constant. Temperature is constant. It means what? What is a isothermal process? Isothermal process is a thermodynamic process where the thermodynamic process will be happening at a constant temperature. Means the affection or the parameters, other parameters like pressure, volume, internal energy, entropy, and again number of moles, all these different thermodynamic variables might change or might be affected at constant temperature whenever the change in state is happening. But one condition, and in the change in state the temperature is going to be constant. In change in state the temperature is going to be constant. The best example is what? Boiling point or melting point or different types of change in state. All this happens at a constant temperature. So that is one of the best examples of what is meant by isothermal process. Boiling point happens means what? Whenever we try to heat the water at 100 degrees Celsius, the water will boil and then later it will convert into vapor state. Until the total water, complete water is converted into the vapor state, the temperature is going to be constant. That is called as an isothermal process, and it is also a thermodynamical process. So now that is a isothermal process. The next one, isobaric process. Here pressure is constant. Pressure is constant. So now it is a thermodynamic process where the pressure is going to be constant. That is called as an isobaric process. So the other example, the example for this isobaric can also be the same thing. It can be even the melting point of water, melting of ice. It can be boiling of water, because the boiling of water happens at the same constant pressure only. So pressure and temperature will be constant whenever the water has been boiled and it's been converted from liquid state to vapor state. So that is again one example of your isobaric process. Now here in isochoric process, this is also called as an isovolumic process. It is also called as what, isovolumic process. Here the volume is constant. The volume is constant. So now it is a kind of thermodynamic process where the volume is constant. Isochoric process is nothing else but it is a thermodynamic process where the volume is going to be constant. The volume is not going to be affected. So this is one of the isochoric process. The next one, coming to the adiabatic process. In the adiabatic process, it is a thermodynamic process where no heat energy is exchanged. The exchanging of heat energy will not be there. It means that the energy exchange is going to be zero. So now here in the adiabatic process, no energy is exchanged. In fact, it's an heat energy. No heat energy is exchanged. So no heat energy is exchanged. In adiabatic process, it is a thermodynamic process where heat energy will not be exchanged between the body and body, different bodies, and also between a body and the surrounding area. So now in a adiabatic process, there will be no heat exchange takes place. Now cyclic process. What is meant by cyclic process? Cyclic process means it is a thermodynamic process where if you consider one thermodynamic system, the initial state of the thermodynamic system will be same as the final state of the thermodynamic system. Means whatever the input we have given to the system will be the same as the output. The output also will be same as the input. Means ultimately even the thermodynamics process has taken place, the input state and the output phase will both are same. That is called as an cyclic process. So ultimately, if you have started from one point, if it has gone through the thermodynamic process, ultimately it comes over here. It means what? The first stage is same as the final stage. So now cyclic process is a thermodynamic process where the first stage of the thermodynamic system will be similar to the final stage of a thermodynamic system. The reverse of that one is a non-cyclic stage where the first stage will not be same as the final state. It will be different. So that is a thermodynamic system, systems, cyclic and non-cyclic process. In the reversible and irreversible process, in the reversible process, if any of the particular system has changed its state during the thermodynamic system, you can even reconvert into that particular previous state. Just like melting point of ice into water and again water back into its solid state. So that is a reversible process. It is a thermodynamic system where it's a thermodynamic process where any kind of system can be reconverted back into its first stage. That is called as a reversible thermodynamics process. Irreversible process means which we cannot convert back, into that particular process. So that is called as a reversible and irreversible process. So now the different types of thermodynamic process are: first one is an isothermal process, second one is an isobaric process, third one is an isochoric process, fourth one is an adiabatic process, fifth one is called as an cyclic and non-cyclic process, sixth one is the reversible and irreversible process. So these are the different types of thermodynamic process. I hope you all have understood about what is meant by thermodynamics, what is meant by thermodynamic system, what are the different types of thermodynamic process, and again what is meant by how a particular system, how a particular different types of thermodynamic systems are to be considered. So this is for this today's lecture. I hope you understood.